Okay, so in this video we're continuing to use the clock model to think about fractions. And here we have our clock, 60 minutes divided into twelfths, right? Into 12 equal sections. And in the first problem we're asked to think of a third plus a tenth. A third, in terms of this clock, is 1/3 of the circle. So if we start here and we go around, we'll end up here, and that's 1/3 of the entire circle. That's 20 minutes. So we can think of 1/3 as 20 minutes, and a tenth, well, what goes into an hour, or for the full circle, 10 times? I think we have 60 minutes, and we're dividing it into 10 pieces. Each piece will be 6 minutes. So every 1/10, right, is just 6 minutes. 6 times 10 is 60, so a tenth is 6 minutes. So that means that 20 minutes and 6 minutes is just like 26 out of 60. And we could reduce that, of course. We could say that 26 is equal to, divided by 2 is 13, and 60 divided by 2 is 30. But we could have stopped here. We're not focusing on reducing fractions here, but to understand how to apply some intuition to these problems. And that's where cool stuff starts to happen here, because if you think of a sixth in the next problem, a sixth of an hour is really just 10 minutes, right? Because 10 times 6 is 60. So that's 10 minutes. And what I mean by cool stuff starting to happen, 1/6 refers to 10 minutes, and 1/10 refers to 6 minutes. Notice that cool connection right there. A tenth of an hour is 6, a sixth of an hour is 10. So there's a nice connection that will keep happening with these model problems, and I think you'll find that quite fun. And I'll leave it to you to think about what's actually happening here, and maybe I'll cover that in further videos. But isn't that neat that relationship happens? So next we have 1/12 to deal with, and again the clock model is perfect for twelfths because it divides time into 12 pieces. And if that's the case, we're given twelfths. So from here to the 1, that's our first twelfth. And that's just 5 minutes. So 1/12 is like 5 minutes. That means we have 15 out of 60 minutes. And we could reduce that, right? 15 divided by 15 is 1. 60 divided by 15 is 4. So that's 1/4, right? Moving on, we have 2/3 plus 3/10. And that's just going to use what we had right here. Except 1/3 was 20, so 2/3, right? 1/3 gives us 20 minutes. So 2/3 gives us 40 minutes. And 1/10 just gave us 6 minutes right here. So 3/10 will give us 18 minutes, right? 6, 12, 18 minutes. Oops. Yeah, 18 minutes. So that's 40 plus, sorry about the color change there, 18. And that gives us 58 minutes, almost an hour, out of 60. Okay, I'm not going to reduce, I'm just going to keep going here. I'm trying to connect these fractions to this model. I'm not trying to show you how to reduce in these videos. So we're moving on, 5/6 plus 5/12, and that's going to use this right here. We said 1/6 was 10 minutes. So 5/6 has to be what? Well, 5 times bigger than 10 minutes. Because it takes 5 of these 1/6 to make 5/6. That means this is 50 minutes. Plus what? Well, 1/12 was 5 minutes. So 5/12 should be 25 minutes. And now we go over an hour. We have 75 out of 60. We keep going. 3/4 plus 3/12. Well, notice here we found what 1/4 was equal to when we reduced the fraction. 1/4 of an hour is equal to 15 out of 60 minutes. That's a quarter of an hour. So 15, it's right here. You can see in the circle, right? That's a quarter. If you had like a piece right here, that's a quarter piece of the whole clock. So 3/4 will be 3 of those pieces. 1 half an hour is 2/4 or half, and 3/4 brings us to the 9. So it fills in the whole thing there, and that brings us to 45 minutes. So it's 45 minutes. Plus 3/12. Remember, 1/12 was 5 minutes, so 3/12 is just 15. And this actually brings us to one full hour. Doesn't that make sense? Because 3/12 is really a fourth. You might recognize that. And 1/4 and 3/4 doesn't make a whole. So now last but not least, we have 4/6 plus 4/12. I'm going to use this step in the string to figure this out. 1/6 was 10 minutes, so 4/6 is 40 minutes. 1/12 was 5 minutes, so 4/12 is 20 minutes. And again, that's 1 hour. And you might recognize this is 2/3, and this is 1/3. So we're adding a 2/3 and 1/3, and makes one whole piece. Alright, more to come.